I have an interesting topic today. So before I start, can I have quick survey? How many structural engineers are sitting here? Just quick survey. Yeah, quite a few. Okay. So just let me tell you quickly a brief background why this topic was selected. This is again my personal experience, which I will be sharing here. So what I observed when I was working with different industries. That when it comes to the steel structure design, and then when it comes to the IS 800 2007, it was launched nearly I believe in February 2008. So this is again my own personal observation. You might have different experience, but while working with different industry and also in different organization, I had a chance to interact with different consultant across the country. Also had a chance to look into the design calculations also. So what I believe that still in certain cases this code is not followed in totality. It is being considered partially in the design. So we will see certain those kind of aspects here. Okay, since we are running too late, as well as we do have a diversified audience here, I'll be moving very fast. So whatever questions you can have, you can note it down, and then definitely we can discuss. So entire content, if we see, it is divided in two parts. First part, you can see that these are all different sections of the Indian standard codes. Definitely we are not going to get into the detail of each section, but it is just only quick remark which I have that I will mention here. And again, it is not too technical, it is going to be too general. And second portion is the way forward, in my opinion. That is, of course, it is very short part in terms of presentation, but it is much important. We will see. Okay. So this is very interesting figure. It shows a complete history of the IS 800 code. That it was released in first instance in 1956, then it was revised in 1962, then in 1984. So up to 1984 it was working stress design method code, and after 1984 it has moved to the limit state design code. So if you see the purple line, that shows the knowledge in the global industry, and in the graph, the hedge portion shows the gap area, which we structural engineer needs to fill, because we are now migrating from the working stress design method to the limit state design method. And also, if we see the American code was revised almost 5 times. From the period of 1986 to 2003 or 2005. But in our code, it is just only first revision. So obviously there are going to be number of challenges. So let's see quickly. So of course there are certain questions in the mind of structural engineers, that why limit state method should be used. Whether structures designed by working stress method, which was conventional method, are going to be unsafe. Why typical, or rather why individual structural engineers should go into the more kind of mathematical jargons that is included in the limit state design method. And of course there are so many practical questions which are there in the mind of structural engineer when this transition zone happens. So in my opinion, these all questions can be answered through the philosophy of the philosophical angle should be considered rather. So what we are going to talk about now, it's a completely overall understanding of the code. We will try to take it very quickly now. So as mentioned here, the confusion faced by the structural engineers can be answered by the philosophical angle, but at the same time it is very much important that entire philosophy should be understood while designing the structure. So let us see. Okay, so IS 807 is the basic code that all we know. There are total 17 sections, 8 annexures, and also references have been made to the international standards like Australian standards, Canadian standards, as well as the Eurocode. So this shows the entire spectra or entire all areas which are covered in the 800/2007, starting from the material methods of analysis, limit state method. Still there is option of working stress design method also. There is earthquake resistant design, fatigue, testing methodology, durability, fire resistance, as well as the fabrication and erection. Okay. So when we talk about limit state method, then of course there is the concept of the acceptable probability that structure should not become unfit for its intended use. That is the basic essence of the method. So when we talk about limit states, those are of two types. One is the ultimate and another is the serviceability limit state. So when we talk about the ultimate limit states, these are related to the failure or complete collapse of the structure. Okay, and when we talk about serviceability limit state, that structure will not be fit for its intended use. So this graph shows very clearly that, see, the blue line shows the applied load and the green line shows the strength. And there is always small overlap between two graphs, and that is the region corresponding to the failure. That means in the limit state design methodology, we consider the probability of the failure of the structure. And by a number of factors, we try to maintain that probability within acceptable level. But when we talk about working stress design method, which was earlier, in that this concept was not accepted. That means failure was not accepted. So of course, because of this now, as we have seen that there is a load and the strength, both are variable, and of course we don't have, there are so many variable factors. So because of that, this partial safety factor for load as well as partial safety factor for the materials have come. And of course, partial safety factor for the materials will depend upon the fabrication as well as erection procedure of the particular country. So when we talk about India, still there are a lot of gaps when we compare our fabrication and erection methodology as compared to the developed countries. So our factors are little bit on the higher side when we compare to the different other standards. Similarly, there are partial safety factor for the loads also. Deflection limits have now been introduced, which is now mentioned for the different members also. Earlier it was a very small table, now the table has been expanded. Now there are 4 types of different sections have been introduced, which is plastic, compact, semi-compact, as well as slender. And at the same time, there are different types of analysis methods have been introduced, which is elastic analysis, plastic analysis, as well as advanced structural analysis. And when we talk about, say, design of tension members, there are 3 limit states introduced, which is yielding of gross cross section, rupture of critical section. But this block shear failure is now introduced. This is a new type of limit state which was not there in the earlier code. This is the typical block shear failure. In compression member also, if we see that there are now 4 buckling classes which have been defined based on the type of section as well as the axis of buckling. Earlier it was only one buckling curve in the 1984 code. When we talk about member subjected to bending, there are again 3 limit states: shear leg, flexural torsional buckling, as well as the shear buckling. Generally, shear leg and shear buckling will not be so much critical for the normal hot roll sections, but elastic, flexural torsional buckling will be critical phenomenon which needs to be considered for the structural design. So when we talk about elastic, flexural torsional buckling, these extract I have taken from my talk at Ahmedabad. Still the entire video is recorded, so if you are interested you can go through, but right now I am running very quickly. That if we don't consider this phenomenon properly, then let us see what kind of errors are going to be introduced. This is typical equation which is given in the 800-2007 code, and this equation is based on the uniform moment concept. And it is mentioned in the code that we don't have uniform moment, and generally our case is going to be like that only. So in that case, we have to utilize annexure E. And this is the equation of the annexure E for the elastic flexural torsional buckling. So here there are three factors introduced, C1, C2 and C3. So also it is known as a three-factor formula also. So let's see quickly what is the difference between this simplified concept and then this annexure E. So this value 1 represents value from the simplified approach. And if we go with the annexure E, the results can be 2.75 times. That means our results will be sections will be 2.75 times conservative if we go with simplified concept. So one time on one side it is become conservative, but in another case, this is with different load conditions and different support conditions, this can become even unconservative also. Now you can see from 1 it is going to 0.3 also. And in generally all popular software right now, it's only simplified concept which is considered. So this is kind of error which we will get in our analysis. Of course, it's just only one code, one clause and one value we are talking about, but there are so many things which we can debate and we can discuss offline. As we just discussed that now this code also allows use of the working stress design also, because there is a transition between working stress to limit state. But there is a myth in certain engineers in certain times when I was discussing. They were telling that because of this relaxation, we can utilize 800-1984 code straight away. But there is a big difference when we talk about working stress design method concept from the 800-2007. It tells that whatever limit states we have discussed up till now, that is say block shear leg, flexural torsional buckling, everything needs to be considered. Only difference between the concept will be that these partial safety factors will not be there. So that means there is a drastic difference between the 800-1984 working stress design method and 800-2007 working stress design method. Okay. Also, there is now very different chapter for the earthquake resistant design. It shows additional load combinations like dead load plus live load plus 2.5 times earthquake load. And there are different types of frames given, which is ordinary concentrated braced frames, then specially concentrated braced frames, and so on. And response reduction factors are also mentioned. Now here there is again one important point which I would like to make. You can read out in the blue color, it shows that frame should withstand inelastic deformation corresponding at a joint rotation of 0.02 radians rather. So what does it mean? That we will have to go for the inelastic analysis straight away. That means the software needs to be upgraded for this kind of analysis. And also it was observed in research and development in other countries that column basis will be the most or rather this will be the one of the location where plastic hinges will be generated because of the rigorous shaking of the building. So because of that, the column basis details have been also made much more stringent in the code. Of course, there are now clauses for the durability also. As we were discussing for the corrosion, we already had a lot of discussion on that, so I will not go in much detail. But now in the code, 5 levels of severity have been identified, like Eurocode: mild, moderate, very severe. Also, there are clauses for the fire resistance also, that what should be the fire resistance level, what we were just discussing in after one of the sessions. Okay, so this is just a brief glimpse I just wanted to give. Okay, that there is a major changes from the philosophy of the 800 1984 to 800 2007 code. And there are still so many points and so many details which needs to be discussed amongst group of structural engineers. So on one side we see there is a technical committee of Bureau of Indian Standard, and on the other side I have shown which is practicing structural engineers. So one innovative initiative was taken in 2012, but still it is in process, that we formed one BIS Codal committee on behalf of Indian Association of Structural Engineers, and right now we are collating queries from all structural engineers across the country. We are collecting those queries, and then we are in process of sending those documents to Bureau of Indian Standard for further consideration. So you can note down this email address, and if you have any query, you can always send to this email address so that it can be forwarded. Okay. So in short, I have very few concluding remarks, that the intent of this keynote was only this, that confusion faced by structural engineer can be understood by the complete philosophy of limit state design method. And the main catch is that this philosophy should be entirely understood. And the most important part, structural engineer should share knowledge on the maybe on one of the common platform on real time basis. Whatever queries, whatever confusion they have related to any code, or even for this code, then that can be discussed, that can be shared. Okay. And this is again most important part which I would like to make, that is the software should be authenticated for the use of limit state design method, the way it has been written. Because see, there are certain automated formulas are still not introduced in our code, and because of that, those are also not those, or rather those have not become part of the software. So there is a very big gap area that also we need to see. Okay. Okay, so thank you. That's all from my side. Yeah.